Kids? All right. The last video we learned a little bit about the intro to angular work or rotational work. So let's do a practice problem. I know practice problems are fun. I will just tell you, if I'm ever having a bad day, sometimes I'll just do physics. You want to know why? Because it makes me feel better. So if you're ever having a bad day, just do some physics and you'll feel better. Okay? But here's our problem. So you have a solid disk. I is 1/2 mr squared. The mass of my disk is 2 kilograms. The radius of the disk is 0.4 meters. It is rotating counterclockwise at a rate of 6 radians per second. Remember, 6 radians per second. That's almost one full circle every single second, because a full circle is 2 pi. A 5 Newton force is applied to the right side of it, and it's applied for 3 full revolutions. Exciting. And we want to figure out how much work was done, and then what is the final kinetic energy of the disk. Okay, so, all right, so physics. So let's say you have this problem, and you're like, I don't know what to do. Well, you know what to do first. You draw a picture. So let's draw a picture that's going to represent the problem. So here's my disk. I know. It's a beautiful disk. I did minor in art, so there you go. And the disk at the start is rotating counterclockwise for 6 radians at a rate of 6 radians per second. Then it says we're going to apply a force on this side, and we're going to apply the force, straight is on the right side. It doesn't say. I'll add that. We're going to apply the force that way, straight up, okay? And we're going to apply it straight up, so right here, this way. Oh, well, that's going to cause a torque, and that torque is going to cause it to rotate faster that way, put your pencil here and hold it and go, oh, if I apply a force that way, it's going to apply a torque in the counterclockwise direction. So later on, my disk is going to be moving even faster. Oh my God. So there was some work done. So if we want to draw our in-between, I have this 5 Newton force going that way. All right, so let's write our equation. Oh, I have kinetic energy. I'm going to call it my initial kinetic energy, or kinetic energy 1. Oh, I have a different kinetic energy over here. Oh, did my kinetic energy change? It did. And in fact, it gained. That means we did some positive work. I know, it's exciting. You make your picture. You write your equation from your picture. Physics is beautiful. All right, well, how do I find this? Remember, kinetic energy is 1/2. The linear one is mv squared. So then rotational equivalent to m is I. Rotational equivalent to v is omega squared. So then if we say my initial kinetic, if I want to solve for that, I would say, all right, I have 1/2 times 1/2 times m, which is 2, times r squared, which is 0.4 squared, times omega, which is 6 squared. All right, let's take out your handy dandy calculator and plug her in, okay? 0.5 times 0.5 times 2 times 0.4 squared times 6 squared. Yeah. Did you do it, or did you just watch me do it? You learn physics by doing it, okay? And you get 2.88 joules. Okay, because again, measured in joules. So this is 2.88 joules. All right. Then we are going to supply my work. If I want to find my work, okay, let's do that. Work is going to be torque times theta. Okay, well, how do I find torque? Torque is force times lever arm. What's the force? That would be 5. What's the lever arm? It's the radius, which would be 0.4. What is my theta? That's 3 revolutions. So that would be 3 times 2 pi. Where hopefully you see there is torque, there is your theta. And then, all right, I'll wait for you. Get your calculator out. Come on. Okay, so if I go 5 times 0.4 times 3 times 2 times pi, I get 37.7 joules. That means we're going to add 37.7 joules, and then I can find my final kinetic. All right, plus 2.88, and lo and behold, my final kinetic is 40.6 joules. And if I wanted to find the final angular velocity, you could do that. You would just have to plug this into here, and then you could solve. But now I know the work done was positive that, and my final kinetic energy, and life is good. I just got happier because I did physics. Bye, kids.